three possibilities. I'm going to show you three possibilities with when you're looking at potential difference and you're saying relative. So let's say like in this problem, it says the potential difference of A to B is 136. So that means that if I'm stacking them and putting the higher one at a higher level on the board, if A to B is 136, then I am going to say that A is 136 and B is 0. Because A to B is 136. If B to A was 136, then B would be up there and A would be there. Or if I already had B on the board as 0, and I said B to A was 136, then A would have to be down here, and I'd have to write negative 136. All right? So I know that. Now it says, while the potential of C to B is 69. Well, 69 is a smaller number than 136. So C would actually fit right in between them. And I'm going to put 69 right there. Now, if the problem had said C to A was 69, then I'd have to make a number bigger than 136 by 69 and put it right up there. All right? If it said B to C was 69, then I'd have to make C negative 69 and put it down there. So now at least I have, now, and it doesn't mean that B means that the potential of B is 0, and that's 69, and that's 136. This could be 1, 70, 137. That could be 2, 71, 138. All that matters is the difference. It doesn't matter where the starting point is, so I just need to know the difference between one and the next one. So the reason why I did that is because then the question says, how much work is needed to move a charge from C to A? So I'm going from here to there. Let me write that in. I'm going from there to there. So I'm raising my potential. Just like if I were lifting something off the ground, the higher I lift it, the greater potential energy I'm giving it. So in this problem, I'm going from 69 to 136. That's going to require work because I'm raising it to a higher energy level. So remember, because voltage is joule per coulomb, so that's the amount of energy per charge that I'm raising it. So I'm going to list my facts, and W is the unknown again. So W is the unknown. And the V, what would the V be in this problem if I want the V to go from C to A? 67. All right, 67 volts, because if I subtract 69 from 136, I get 67. So to go from there to there, I have to go up 67 volts. So there's my V. They also gave me the charge. So the charge in the problem, QO, is 23 microcoulombs. So 23 microcoulombs, I'm going to write that as 23 times 10 to the negative 6 coulombs. So those are my facts, and they don't give me anything about R in the problem, so probably R is not needed. Now, since W is the unknown, I'm going to do it like I did the other one. I'm going to put W, and I'm going to put V, and W is KQ, QO over R, and V is KQ over R. So you can see both of them are R. Like if I had one that was R and one that was R squared, they would have to have given me R. But the only thing that's different between the two is the numerator. So what I have to do is, to make the numerators the same, I'm going to multiply this side by QO. Whatever I do there, I do up here. And now since these two are equal, those two are equal, and now I have the formula that I can use to solve for the work based on the variables that I know in the problem. So my answer is just going to be W equals V QO. Now when I write V, I'm not going to write volts because I want to show how the units produce joules. So I'm going to write this as 67. A volt is a joule per coulomb. So I'm going to write it like that. And then I'm going to multiply that by 23 times 10 to the negative 6 coulombs. You can see that my coulomb will cancel with my coulomb, and my answer will be in joules. So if you multiply those together, you're going to get your answer as 1.54 times 10 to the negative 3 joules. Any questions with that one?